The United States Air Force is undertaking a comprehensive and transformative modernization of its B-1B Lancer strategic bomber fleet through the development and integration of advanced external pylons, known as the External Heavy-Stores Pylon program. This initiative reflects a deliberate and future-focused approach to sustain, enhance, and expand the mission effectiveness of the B-1B through the latter half of this decade. It addresses critical national defense priorities, including long-range strike readiness, force survivability, and the ability to generate significant standoff firepower from a legacy airframe during a critical transitional period before the full arrival of the B-21 Raider. The B-1B Lancer, which entered service in the 1980s, was originally designed for low-altitude, high-speed nuclear penetration missions. Following the end of the Cold War and strategic arms reduction agreements, its nuclear capability was deactivated, and the aircraft was adapted for conventional missions. Despite being more than 4 decades old, the B-1B remains an integral part of the United States long-range strike triad due to its speed, range, and massive internal payload capacity. However, the Air Force recognizes that further relevance and combat value can be extracted from the aircraft by taking advantage of its dormant external carriage capability. Each B-1B was originally built with 6 external hardpoints designed to mount cruise missiles during its nuclear strike role. These stations, located under the fuselage between the engine nacelles, were largely left unused following its conversion to conventional-only operations. However, in recent years, engineers and strategists began re-evaluating this feature as a possible force multiplier. Rather than designing an entirely new aircraft or making expensive structural overhauls, the Air Force could leverage these underutilized stations to dramatically increase the B-1B's weapons capacity by installing newly designed external pylons. Boeing's Load Adaptable Modular (LAM) pylon system was developed as a result. These pylons are capable of carrying heavy and oversized weapons while remaining modular, scalable, and compatible with existing aircraft structures. Each pylon can carry either 2 standard 2,000-pound class weapons or a single weapon in the 5,000 to 7,500-pound range, depending on future certifications and testing outcomes. A total of 6 pylons per aircraft would provide a massive expansion in total weapon loadout, without compromising the aircraft's internal bomb bays. This modification allows the B-1B to perform an even more formidable long-range strike role by maximizing its payload-to-sortie ratio. The current fiscal year 2026 defense budget includes a $50 million line item to formally initiate the External Heavy-Stores Pylon program. The Air Force designates this as a New START program, which will now begin transitioning from test and demonstration to fleet integration. The funding covers extensive testing, modeling, structural assessments, and full aircraft integration steps. These include computational fluid dynamics (CFD) modeling to analyze airflow and aerodynamic stability with pylons installed, wind tunnel testing for vibration and stress effects, and design refinement to aircraft wiring, mission computer software, pylon interface points, and control systems. The upgrade also includes modifications to existing line replaceable units (LRUs) that connect to the pylons. Additionally, the Air Force will implement updates to the B-1B's weapons management systems, enabling pilots to monitor, configure, and deploy weapons from these new external stations in real time. It is expected that the aircraft's total digital architecture will be updated to account for the new capabilities, requiring deep software integration and interface validation. Beyond hardware improvements, this effort supports a broader strategic objective, enhancing standoff firepower at scale using legacy systems. While stealth platforms such as the B-2 and the upcoming B-21 provide vital penetration strike options, not every mission requires stealth. There is growing recognition that conventional bombers like the B-1B, when outfitted with long-range munitions, can deliver persistent strike capacity at lower cost and risk in certain environments. With extended weapon carriage, B-1Bs can saturate targets from long distances, remain outside the engagement range of modern surface-to-air missile systems, and contribute to overall strategic depth without relying exclusively on limited stealth bomber inventories. Importantly, this upgrade also offers a valuable hedge against risk in the B-21 Raider program. Although the B-21 is progressing through flight testing and early low-rate production, its highly advanced systems, stealth materials, and digital infrastructure create significant acquisition complexity. Any delays in production scaling, cost overruns, or integration challenges could result in temporary capability gaps. By extending and modernizing the B-1B fleet, the Air Force ensures there is no degradation in long-range precision strike capability while awaiting the full operationalization of the B-21. Parallel modernization efforts are also underway to enhance the B-1B's survivability and connectivity. The Air Force is replacing the aircraft's current AL-50 towed decoy system, which is used to distract and deflect radar-guided missiles. This system, developed in the 1990s, is increasingly inadequate against modern threats. A replacement effort seeks to develop a more advanced decoy or electronic countermeasure system capable of defeating advanced enemy radar and missile systems. This upgrade is considered essential to enable the B-1B to survive in high-threat airspace during large-scale combat operations. In addition, the Air Force plans to install a new hybrid satellite communications system on the B-1B. This system will increase the aircraft's bandwidth, resilience, and redundancy for long-range missions, especially in contested or jammed environments. The capability will allow for real-time targeting updates, mission retasking, and enhanced joint force integration, key enablers in the modern battlespace, particularly in regions where dynamic targeting and over-the-horizon command and control are critical. As of mid-2025, the B-1B fleet consists of 42 aircraft, following the loss of one airframe in a crash. The Air Force plans to restore 2 additional aircraft from storage, bringing the active fleet back to 44. These aircraft will be equipped with the same modernization packages, ensuring uniform operational capability across the fleet. The Air Force is also funding increased readiness and test capacity for the B-1B, with Dyess and Ellsworth Air Force bases serving as key operational and developmental hubs. Boeing, in its public release, highlighted the LAM pylon's development as a model for rapid innovation. The company's engineers were able to fast-track the project, delivering flight test-ready pylons in less than half the time typically required for such modifications. This was accomplished through a combination of digital engineering, virtual modeling, and collaboration with Air Force test squadrons and acquisition offices. Boeing stated that the pylons provide more mass and flexibility in rapidly evolving combat environments, and praised the Air Force for its proactive role in defining and executing the project under tight timelines and budget constraints. Operationally, the expanded weapons capacity will allow each B-1B to engage more targets per sortie, deliver greater volume of fire, and adapt its loadout to mission-specific requirements. Whether launching a precision strike campaign, suppressing naval formations at range, or delivering area denial effects against forward-deployed enemy infrastructure, the B-1B will be able to contribute with greater efficiency and lethality. The combination of internal and external payloads also enhances its deterrence value, as adversaries must consider the bomber's ability to conduct large-scale, precision-guided weapon strikes without entering defended airspace. While the B-1B's eventual retirement remains on the books for the next decade, these upgrades ensure that the aircraft will remain a highly relevant and capable platform throughout its remaining years of service. The modernization program, anchored by the LAM pylons, reflects a broader Air Force strategy to bridge the gap between current and next-generation strike capabilities using cost-effective, high-impact upgrades. It also demonstrates how legacy platforms can be adapted to meet new challenges without requiring complete replacement, offering strategic flexibility in a dynamic global security environment. The B-1B Lancer's pylon upgrade is a strategic, operational, and technological advancement that greatly enhances the U.S. Air Force's ability to project power globally. Through increased payload, advanced systems integration, and improved survivability, the B-1B continues to serve as a cornerstone of U.S. long-range strike operations. The program underscores the importance of maintaining adaptable, modular capabilities that evolve alongside the threat landscape, ensuring that the U.S. retains credible and overwhelming force options at all times.